Hello and welcome to this short video on advanced automation issues. We will look into one of problems that we can encounter in the automation process, and we'll see two simple cases as an example and their potential solutions. I will cover a topic of config true data that should be config false. Whole video will show two separate examples of problems that we may encounter in relation to config true and config false data. I will describe the problem and hint on how one can possibly address the issue. First case or example will be about constraints on configuration data. The second one about nested config false and config true data. Typically, we use the Yang module to specify and model target devices configuration and operational state. Our first example is about using the Yang module to implement the constraints and limitations of the device. When we create Yang models, we can often see an extra information embedded into configuration nodes. Created model includes extra items like settings for restricting parts of the config, enabling of features or licensing details. Don't repeat yourself. One of the clean code principles that can make sense in Yang modeling as well. Sometimes we create a general model that describes family or range of devices. We specialize the model for a device by configuring and setting some restrictions as a part of configuration. We can reuse the same model with different initial configuration across multiple devices. How can we make generic models specific to a target device? For example, number of interfaces supported on device, specific routing protocols, or business logic being available. These are not the real items that are configurable in runtime typically, or without need of manipulation or intervention with the device hardware. Is there some alternative solution? We should not use the model configuration itself to specialize model. Let's allow configuring the general model even for non-available features, and then we can use the device's operational state to reflect on the correctness of configuration. What's the advantage of this approach? Same model with reduced size and complexity. There is no device-specific restrictions present in the configuration nodes. We can easily transfer the configuration instances of specific devices between different models and no problem as needed. Let's see some trivial example here. On the left, we have not that great model. There is a configurable limit on number of blades that can be set for some sort of router. On the right, we have alternative model. There is no extra config. We have extra operational status to show effects of the configuration. Do we have too many or extra unsupported blades? They will be shown as not present in the simplified model example. Let's look at another case mentioned in the beginning of this video. Nested mix of config true and config false data. Side-by-side mix of different config true false is not a problem. Our case describes configurable items that should be nested inside of config false data. Such case is not allowed by netconf or Yang standard itself. Similar needs can occur when there are config false items that are not created by our explicit actions, but the data still contains some parts that needs to be configured. How can we model this? A saving thought might come. We could change the root config false node to be config true, but it creates new problem of course. We have all the new configurable items that we don't want to configure. There is an extra effort needed to keep the configured items in sync with the real state as well. How to address the problem? The most straightforward path is to utilize the network management data store architecture. As an alternative, we could do some cloning of the conflicting parts of the model, as we will show on the following slides. NMDA, the RFC 8342 provides details on the extended set of data stores that the standard brings in. The whole problematic subtree we could change into config true data and utilize the NMDA's operational data store to display and allow configuration of necessary items. As an alternative solution, parts that need to be configured can be either hidden from the original model or kept config false. As a next step, we add a config true clone or side model of the original tree structure, but including only and only all the configurable items. We leave out all the config false original data. If the synchronization is needed, we either provide action to populate the config true key values and config true parts, or we manage ad hoc as specific project architecture requires and allows. On the left, we have original invalid model with config true items nested inside of config false. On the right, there is a trivial example of side-by-side clones and config true and config false data separated into sibling subtrees. Here we have a list of resources, a few links to web pages that could be of interest, a network service orchestrator, confd configuration daemon, a netconf and Yang automation testing, and a YouTube channel that includes this and other videos related to automation principles. Thank you for watching this short video, and I hope you found some useful information. Have a nice day!